All right, you guys, so this lesson is lesson 3-2. It's me talking about specifically parallel lines and transversals. Okay, so everything we're dealing with today is dealing with parallel lines. So if you remember, parallel lines are two lines that never intersect. I've got one set of the pair, here's the second set of the pair, and then we have our arrows showing that these are our parallel lines. And then remember, the transversal is the line that passes through those two parallel lines in this case. So what you need to know with parallel lines is those angles that we learned yesterday are going to have certain relationships. So if you were to take a protractor and actually measure this angle right here, okay, let's say it's 70 degrees. Just knowing that that one angle is 70 degrees is actually going to tell you what every one of these 8 angles is going to be. Obviously, you know that this is 70, but you're going to be able to tell what this angle is, what this angle is, this angle, this angle, this angle, this angle, and that angle. Okay, and it's all because of these theorems. So first of all, just knowing that this one angle right here is 70 automatically tells you that the angle across from it is also 70. Remember, that's the vertical angle theorem, right? Whenever you have two straight lines that intersect, you automatically know that they're going to be, the angles across from each other are always going to be congruent. So that's why both of these are 70 degrees. We also know that we have some linear pairs, right? If I look at this line and then this line that intersects it, we actually have a linear pair with the 70-degree angle and this angle right next to it. So those two angles must add to 180 degrees. So that means that this one must be 110 degrees. Now, knowing that that's 110 also tells you that the angle across from it is 110 because of the vertical angle theorem. Now, what's great about this is that when you have parallel lines, you automatically have this exact same situation with these 4 angles right over here with these 4 angles. Okay, so if we actually measured these, again with a protractor, you would be able to tell that this is 70, this is 70, and then these are also both 110. Okay, so what's important about this? All the angles you learned yesterday are going to have certain relationships. So we learned corresponding angles. Remember, those are the ones in the same location. Look at the corresponding angles. Here's upper right. Here's upper right. Notice how they're both 70. Here's bottom right. Here's bottom right. Notice how they're both 110. Here's upper left. Notice how it's 110. Here's upper left. And then same thing with bottom left. Both 70. Okay, so corresponding angles are always congruent. Likewise, we have alternate interior angles. Remember, alternate interior angles are the ones inside of our two lines. So our two parallel lines are these two. So they have to be on the inside of these, and they have to be on different sides of our transversal here. So for example, this 70-degree angle is an alternate interior angle with this one, and notice how they're both exactly 70. Likewise, these are both alternate interior angles, and they're both 110. So alternate interior angles are also both congruent. Then we've got alternate exterior angles. Remember that alternate exterior angles are on the outside of these two parallel lines and on different sides of this transversal. So alternate exterior angles are, let's see if I can pick a different color here. Okay, so if you can see this blue that I'm highlighting over here, that's on the outside of these two parallel lines and on different sides of the transversal, and they are both 110. Okay, another pair of alternate exterior angles would be these pair that were both 70. Okay, so alternate exterior angles are also congruent. And that leaves us with only one other type of angles, consecutive. Remember, C, the C. Okay, so if I look, consecutive have to be both inside the parallel lines and the same side of the transversal. So it's actually these two angles right here. And if you look, that angle makes a C. If you look, this angle right here is 70 degrees. And then this angle right here is 110 degrees. So consecutive angles aren't congruent because they're both not the same. Well, in this situation, they aren't. They could both be congruent if they were both 90. But the main thing you need to remember about consecutive angles is that they're supplementary. Remember, supplementary mean that they add to 180 degrees. Okay? And that also works for the other side. So if I look, here's my other C. This angle is 110. And then I have this one, which is 110. So it ends up looking like this. This one was 110. This one was 70. And again, you can see that C is just kind of like upside down and backwards. But those both also add to 180. So consecutive angles are always supplementary. All right, so that's something you're going to want to memorize. That corresponding alternate interior and alternate exterior are always congruent to each other, whereas consecutive angles are always adding to 180. Okay, so that's what these theorems tell us. We have the corresponding angles are always congruent, right? And of course, they have to be cut by parallel lines. If you don't have parallel lines and you're cutting these by a transversal, you can definitely tell that the corresponding angles are not the same size, right? This looks much smaller than this one, okay? So you have to have parallel lines in order for that to happen. Alternate interior angles. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So basically, these theorems are telling you exactly what I already talked about here. Then we have alternate exterior angles. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. And of course, the last one that's different are consecutive angles. If consecutive angles are formed by two parallel lines and a transversal, then the consecutive angles are supplementary. Remember, that's the one that's different, right? Supplementary means they add to equal 180 degrees. All these other ones are congruent. Okay? Okay, so in this example, it says find the missing measures and justify your answers. So I want you to go ahead and take a minute, figure out what all the missing angles are going to be. Again, just a reminder, this 2 does not mean that this is 2 degrees, right? You have to use your other knowledge to be able to come up with how many degrees it would be. So go ahead and press pause, and we'll have you guys go ahead and try this. I know this is very similar to the one we just went through, but I need you to practice this part, the justify your answers. Okay, so think about what specific theorems you're using as you go through it. And your method will probably be different than your neighbor's, okay? That's totally okay. And the way that I'm going to show it in a second will probably be different than the way that you thought of it. But as long as you have a way to justify how you came up with it, you're not wrong, as long as, of course, you're using the correct justification. All right, so go ahead and give it a try. Okay, so I'm assuming now that you have completely answered these. So I'm going to go ahead and do this. So for me, I always like to start with vertical angles. To me, it just makes sense. So for example, if I know that this one is 70, I know that 3 must be 70 using the vertical angle theorem. Now from there, I'm going to use the linear pair postulate, right? The linear pair postulate says that when you have a pair of angles that form a linear pair, that they're supplementary. So I'm using this 70, and I'm going to use angle 2 to say that this one is 110. Now from there, I'm going to use vertical angle theorem again to come up with 4, right? I have both this angle 2 and this angle 4 that are vertical angles. So I'm using the vertical angle theorem to come up with that one. Okay, from here, I have lots of ways I can come up with angle 5, 6, 7, and 8. So I'm gonna go ahead and come up with 5. I'm gonna use, I'm gonna use the fact that 5 and 3 are alternate interior angles. And if I have parallel lines, which I do, right? These are both parallel. Then since 3 is 70, 5 is also 70 degrees. And again, that's the alternate interior angle theorem, because I'm using 3 to come up with 5. Okay, so now I'm gonna switch it up here. I'm gonna use the fact that 2 and 8 are corresponding angles, and corresponding angles are always congruent. So I could say that 8 is 110 using the corresponding angle theorem. Okay, now from here, I could use the vertical angle theorem to come up with 5 and 7 being the same, okay? But let's see, I'm gonna try to practice some other ones for you, so that way you'll see that there's lots of correct ways of doing this. So I'm gonna go back to that 70-degree angle, this one that I was provided with up here, and that happens to be an alternate exterior angle with angle 7. So I've got this 70 degrees right up here, right here, and 7 are going to be alternate exterior angles, and alternate exterior angles are always congruent when you have parallel lines. So practicing the alternate exterior angle theorem. Okay, and then let's see. I think I've practiced everything for you except for consecutive, and that's okay. So I'm going to go ahead and just use the vertical angle theorem again, right? If 8 and 6 are vertical angles, then 8 and 6 are congruent. So 6 is also going to be 110. So there are many correct ways you could go about this, okay? It all depends on the order that you're trying to figure it out and what you personally decided to try. So lots of correct ways of doing it, as long as, of course, you're naming them correctly. Okay, so in this example, I want you to go ahead and figure out what X is, and I want you to explain how you came up with it. Okay, so go ahead and take a minute, set up an equation of some sort to figure out what X is, and then explain how you knew that it was going to be that. If you're stuck, one thing that might help is to use this 120 degrees and then come up with what every other angle would be in all of these 8 angles, right? There's 4 up here and then 4 below here. Okay, so if you're stuck, that's where you could start. Okay, so go ahead and press pause and give it a try. Okay, so I'm assuming that you've already done this. So I'm gonna go ahead and I'm gonna answer what all these angles are like I suggested. Okay, you might not have had to do that, but I'm gonna go ahead and do that. So I know that angle 3 is a vertical angle with that 120, so it's equal, because vertical angles are always equal using the vertical angle theorem. So I'm gonna write that that's 120 degrees. And then from here, I'm gonna use that C to C thing, because I know that I've got this little angle. These both of these angles make that letter C. These are called consecutive angles. And remember that consecutive angles are supplementary. Okay, that was a consecutive angle theorem. So that would mean that if I take angle 3, which is 120 degrees, and I add it with this angle, which is x plus 5, it's got to equal 180 degrees. So now I just solve. So I'll combine my like terms. So 120 and 5 gives me 125, plus I still have the x equaling 180. And then to get x alone, I just had to subtract 125. Okay, so I end up getting 55 degrees. And actually, I guess I wouldn't call it 55 degrees, right? Because the angle's not actually 55 degrees. The actual angle is 60, right? So I'm going to go ahead and get rid of that degree symbol. It should just be that x is 55. All right, so go ahead and give this one a try. See if you can come up with x's again. So press pause, and then once everyone's had a chance to do it, go ahead and press play. Okay, so I'm assuming that everyone has tried this. Again, there's lots of correct ways of going about this. I'm going to just try to demonstrate a few different ways. Again, because these are parallel lines, I can use this relationship. If they weren't parallel and it was drawn like this and we didn't have little arrows showing that we had parallel lines, you wouldn't be able to say that alternate exterior, alternate interior, or corresponding angles are congruent. Okay, so you have to know that they're parallel. That's what the theorem is. You have to know they're parallel. So I'm going to use the whole alternate exterior angle theorem. So it says if you have parallel lines, then the alternate exterior angles, which these are both on the exterior of our two parallel lines and they're on different sides, are congruent. Okay, and then I'm going to use the linear pair postulate to figure out that this angle is going to be supplementary with 136. So if I subtract 136 from 180, I'm left with 44 degrees. So this is 44. So that would mean that 7x plus 9 equals 44 degrees. Okay, so that's one way. Another way might be that you wanted to do 136 plus 7x plus 9 equals 180. That will give you the same answer. Okay? So basically what you're doing in this situation is you're subtracting 136, and now I have 7x plus 9 equals 44, just like I already had over here. Okay, so to solve, we just subtract 9 and divide by 7. So we get x equals 5. All right, so go ahead and flip to the back side of our notes. I'm going to have you guys go ahead and do this you try here. I know I've already kind of had you guys try these on your own, but I think you can handle it. I believe in you. You know that. I always believe in you guys. Okay. So it says, find the measure of each angle. Be prepared to explain what theorem you use to find each angle. Okay, so go ahead and press pause, give it a try, and then we'll go from there. Okay, so I'm hoping that we were all able to come up with these on our own. So again, the way you did it is probably different than the way that your partner did it, and the way different than the way I did it too, and that's totally okay. So I'm going to kind of skip around. One thing though that you really need to know is that you have to have parallel lines in order to do this. And technically, what did I forget to draw in my picture? I forgot to add arrows. Okay, so technically we didn't even know if these lines were parallel, but let's assume that these actually are parallel lines. Okay, again, they're parallel as long as they have the same number of arrows. So if one had 3 and the other one had 2, we wouldn't assume that they're parallel. So I'll add in the extra arrow just to show that they are parallel. So we are going to assume in this one that they're parallel. And let's see, I'm going to kind of skip around. So let's see, I'm going to start with a linear pair postulate. So I know that angle 2 is going to be 75 degrees. I had to think about that for a second. Should not have had to think about that for a second, but I did. So I know that that is 75 degrees because of the linear pair postulate. Okay? Now from there, I'm going to use consecutive angles. You don't have to. Again, this is just one method. I'm trying to show you all the different ways you could go about doing this. So remember, see the C? There's that C. It's just like rotated. So I know that consecutive angles are supplementary when I have parallel lines. So that would mean that angle 8 is 105 degrees. And let's see, what do I want to use next? I'm going to use vertical angles. So now that I know that this is 105, I know that angle 6 is 105 because of the vertical angle theorem. And let's see, maybe I'll use corresponding next. So 6 and 4 are corresponding. So corresponding angles are equal using the corresponding angle theorem. And let's see, maybe I will use linear pair postulate to say that 3 and 4 are going to make a linear pair. Okay, so this would be 75 degrees as well. And let's see, I'm going to change this to have the little 2 arcs because otherwise it's confusing with my notation. And then let's use alternate exterior angles. So angle 3 and angle 7 are alternate exterior angles, and alternate exterior angles are always congruent when I have parallel lines. And then that leaves me with angle 5 being 75 degrees. And I'm going to use that 7 and 5 are vertical angles. So the vertical angle theorem told me that. Okay, so again, there's multiple different correct ways that you could go about figuring out what all of those missing angles are. Okay, so I want you to go ahead and, again, press pause, try to find x, and then once you're done, you're good. Okay, so hopefully we all solve for x. Again, there's multiple correct ways. We do have to assume something though. Technically, you shouldn't be assuming anything in geometry. We should have arrows drawn here. Bad no-no here from Mrs. Ethorn, okay? We should have arrows showing that these are parallel, because if they're not parallel, we don't know that certain angles are going to be congruent. Okay, so let's see. I'm going to use corresponding angles. So if this is 68 degrees, I know that 7 is also 68 using the corresponding angle theorem. And then I can use the linear pair postulate to figure out what this angle is. So since angle 7 is 68, 68 plus this angle I just marked off in red are going to add to 180. So that would mean that this one is 112 degrees. So now, if that's 112 and it's also 2x plus 4, I can set them equal to each other and solve for x. So all my like terms are combined, so I'm going to move the 4. That leaves me now with 108 equaling 2x. And then to get x alone, I just divide both sides by 2. So I get x equals 54, and I am done. All right, so last example of today. It's supposed to be a real life example. You like that rainbow I drew for you? I know Ella would love it, my daughter. We've been out trying to get outside and enjoy the weather when it's nice out, even though we're all sick. So we've been drawing lots of rainbows on our driveway. Okay, so anyways, it says when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, which is my daughter's favorite color, purple, the measure of angle 2 equals 40 degrees. And it says, what's the measure of angle 1? How do you know? So we are assuming in this, of course, that the sunlight's rays, these right here, are parallel. Okay? And it tells us that angle 2, which would be this angle right here, that is 40 degrees. And it says, what's the measure of angle 1? So the question for you guys is, what kind of angles are those? If I mark it off, what kind of angle is this one and this one? Assuming, of course, these are parallel. Hopefully you're thinking in your mind, alternate interior angles, okay? So the measure of angle 1 is going to be the exact same as angle 2, which is 40 degrees, and that is because of the alternate interior angle theorem. Okay, so if you actually reread the theorem on the front, it says if two lines are parallel, which I've got two parallel lines right here and here, if they're cut by a transversal, which is this line, then alternate interior angles are always congruent. Okay? All right, so that is it for our lesson today. So you guys know where our classroom set of books are. You can go ahead and use the rest of the hour to complete these homework problems. We're doing page 135, 3 through 13, and then 17 and 18. All right, hope you guys are having a great week. I miss you. See you soon. Okay.